Hi guys, welcome to EduUdr. This is Prajithlal and today I am gonna show you some basics of electronics. So, what is electronics? Electronics is a branch of science that comprises of physics, engineering and technology. So, electronics deals with emission, flow and control of electrons. The two main classifications of electronics are analog electronics and digital electronics. So, as we said, electronics deals with emission, control, and flow of electrons. So, what is an electron? Electrons are subatomic particles. They are mobile with negative charge. Mobile means they can move around. So, let's see the structure of an atom. This is the structure of an atom. At the center of the atom, we have positively charged protons and chargeless neutrons. So, this is the core of an atom. So revolving around the core in fixed orbits, we have electrons. So these electrons are movable and they have negative charge. So these orbits are called shells and the outermost shell is called valence shell. So these shells have holes or vacancies for electrons to occupy. So at the first shell we have two holes, so two vacancies for electrons. So the first shell is completely filled. There is a second shell where we have four electrons vacancies, but here only one electron is present. So we have three vacancies there. And the next shell, if there were present a next shell, the third shell, there must have been eight vacancies. And the number of vacancies goes on as the number of the shell increases. So let me say what is an electric current. The movement of electrons can be called as electric current. For an electric current to take place, there should be a potential difference. So there is a potential between two points and there should be a difference in those potential for the electric current to take place. The direction of electric current is opposite to that of flow of electron. So these two statements will be discussed next. So electric potential difference, that is volts. The difference in energy charge carriers have between 2 points is called potential difference. Okay, so let's see a battery. Here this is the negative terminal and this is the positive terminal. So the difference in the potential between these 2 points or these two terminals is called potential difference, electric potential difference or volts. So that potential is the voltage of the battery, as you can see, 9 volt. So electrons are high Electrons are at higher potential at a point while there is lower potential at another point. So as we said, the charge of an electron is negative. So at this terminal, the potential of electron is higher, and at this terminal, the positive terminal, the potential of hole is higher. So what happens is that if we connect a conductor between the points, electron flows from higher concentration or higher potential to lower potential. So this negative side we have more electrons. So electrons flows from here to here. Suppose we connect a conductor here, electrons flows from here to here, and the direction of electric current is opposite to that. So we can say that electric current is formed. Let me explain that. This is the current through a conductor. Electric current through a conductor. Suppose we have a negative terminal and a positive terminal. This is having positive potential. This is having negative potential. So let me introduce a conductor between these two terminals. So we place a conductor. What happens is that these electrons in the negative side will pass through the conductor to the positive side and occupy these vacancies or holes. So these electrons will flow through the conductor and occupy these spaces. And flow of electron takes place and the direction of electric current is opposite to the flow of direction of electrons. So theoretically, electric current is the charge flowing per unit time. So let electric current be represented by the term I. So I equal to Q by T, where Q is the charge and T is the time, and the unit of electric current is ampere. So charge of an electron, as we said, the electrons passes through the conductor and gets to the positive side. So the current passing through is charge flowing through this conductor per unit time. So charge of each electron, each electrons, they have a specific charge, that is 1.6021 etc. into 10 raised to minus 19 coulomb, the unit of charge. So if time is 1 second, then for 1 ampere current to flow, it needs 6241509 into 10 raised to 9 number of electrons. So this much number of electrons need to pass from this negative to this positive for us to say that 1 ampere of current flow has taken place. Under the condition, time is 1 second and ampere current flow is 1. So let's see how we found out. So we have Q equal to IT, that is rearranged from this equation. And when T equal to 1 and I equal to 1, so the time and current we need is 1 ampere and time is 1 second, then Q is also equal to 1. 1 into 1 equal to 1. So the total charge is 1, and we know the charge of an electron is this much. So divide the total charge by charge of each electron. So what happens is that 1 divided by this much. So 1 divided by this much gives the number of electrons. That is exactly this. Types of electric current. The first type of electric current is direct current. So in direct current, we have constant current flow through to a conductor, and the voltage to time VT plot is a straight line. As we can see, in this axis we plot the voltage, and in this axis we plot the time. So what happens is that at every instant of time we have a constant voltage and hence a constant current. So this is direct current. Next one is alternating current, and the electric charge flows in two directions, and the VT plot is sinusoidal. So what happens is that at the beginning it will begin from 0 and attain a peak value and then comes back to 0, and this then goes to negative peak value and then comes back to 0. So this is what happens with an alternating current, and this is the voltage path. As voltage is proportional to current, the current will also be having this path, that is alternating current. Electrical properties of elements. Electric current needs a suitable medium allowing movement of electrons. Elements that allow electric current through them are called conductors. That means that those elements that allow the movement of electrons through them are called conductors. And good conductors are having one electron at their valence shell. So as we can see, this is the atomic structure of copper and silver. So they are good conductors and they have only one electrons at the outermost shell, the valence shell. Next, we're going to discuss about insulators. Insulators are those elements that does not allow electric current through them. So good insulators are elements having 8 electrons at their valence shell. So as we said earlier, if the outermost shell, the valence shell is completely filled, then there will not be any vacancies for electrons and the electric current or the movement of electron does not take place. Next is the semiconductors. They are special elements that act as insulators at a lower temperature, and at higher temperature they act as conductors. That means at lower temperature they will not allow electric current to flow through them, and at high temperature they will allow some electric current to flow through them. So semiconductors are having 4 valence electrons. As you can see, silicon and germanium are semiconductors and they are having 4 valence electrons. The property with 4 valence electrons is that at lower temperature they cannot lose these 4 valence electrons. As the temperature increases, what happens is that the bonding between these valence electrons to the atom will reduce and they will be ready to give away electrons. Next is Ohm's law. Ohm's law states that the current through a conductor is directly proportional to the voltage applied across the two ends. So here we have a conductor and at the two ends we are applying a positive and negative potential, a potential which is a voltage. So what happens is that current starts flowing in this direction from positive to negative, and the electrons must be flowing like this, opposite the direction of current. So V proportional to I, where the constant of proportionality is called resistance. So V equal to IR. Constant is resistance R. Then resistance can be derived by V by I. So this is Ohm's law triangle. If we know the voltage and resistance, we can find the current. If we know the resistance and current, we can find the voltage. And if we know the voltage and current, we can find the resistance. That is what up to this. Resistance R is the measure of opposition to current flow. So the constant of proportionality from a conductor is the measure of opposition to current flow and is called resistance. The unit of resistance is ohm. Here we can see, let this be the resistor or a conductor. We have applied a voltage and the voltage is pushing the current. So the resistance is opposing the current through the conductor. This is illustrated here. So resistance is directly proportional to length L of the conductor and inversely proportional to area of cross section A. So R proportional to L by A. So here we have a conductor and its area of cross section is A and length is L. Now we have to find the value of resistance by giving a constant of proportionality, R equal to rho into L by A, where rho is the constant of proportionality and this constant of proportionality is called resistivity. Resistivity rho. Resistivity is a unique property of the material itself called specific resistance. So resistivity is the opposition to electric current and the unit of resistivity is ohm meter. So different materials have different and unique rho value. That means if we take two elements, say copper and silver, the resistivity of copper is unique and silver is also unique. So they have different rho value and they are having that unique value for their own. So if we have an unidentified element of known cross section and length, we can measure its resistance and calculate the resistivity, hence identify the element. So rho equal to R into L by A, where R is the resistance, A is the area of cross section and L is the length. Thus, if we can arrange the length, area and resistivity, then we will get the desired value for resistance. Thus, we can design a resistance. So, we are given a copper wire. Its area is given as 0.002 square centimeter. So, we are given the task to make 5 ohm resistance. So, what we have is a copper wire. Its area is given. So, we need to make a 5 ohm resistance. So, we have the equation resistance R equal to rho into L by A. So, as we said, each element have a unique rho value. So rho value for copper is 1.68 into 10 raised to minus 8 ohm meter and the area is given as 0.02 square centimeter. So we need to find the length of the wire needed to get 5 ohm resistance. Now put the values in the equation. So R equal to 5. So 5 equal to 1.68 into 10 raised to minus 8 into L by 2 into 10 raised to minus 6. This 0.2 into 10 raised to minus 6 represents the conversion of centimeter square to meter square. So we will get L equal to this much and the final value will be 59.5238 meter. So to create about 60 meter of copper wire of this area cross section is needed to create a resistance of 5 ohm. So copper wire is a good conductor, so not suitable to make resistance. It has lower resistivity but high conductivity. So conductance G is the reciprocal of resistance and its unit is Siemens. So we can also say in per ohm. Conductivity sigma is the reciprocal of resistivity rho. Conductivity is sigma equal to 1 by rho and unit is Siemens per meter. So we can also say it in ohm per meter. So let's try the above problem with the nichrome wire of same area of cross section. So we have the nichrome wire, but the resistivity is unique for this element also. So we have a different resistivity value, rho value. So let's put the value of resistivity here. What happens is that For this much of resistivity value, we need only 0.66, that is about 66 centimeter of nichrome wire to get 5 ohm resistance. So nichrome wire with the same area of copper wire only needs 66 centimeter, while the copper wire needed about 60 meter to make 5 ohm resistance. So I can assure you that this equation can be used to make resistor in electronics. But nowadays we are using carbon composites or polymers with high resistivity instead of metal wires. Thank you for watching EduUdr. We, the EduUdr team, humbly request you to give your valuable feedbacks in the comment section. If you haven't subscribed to our channel, please subscribe and like and share with your friends.